Just a quick reminder, we're working on system of equations. We're going to be working with substitution and elimination. We'll get to that one in just a second. We're still looking for 3 possible solutions. It's either going to be one solution, no solution, or infinitely many solutions. All right. So what we're going to do is we notice that y is equal to 5x on this equation here. Okay. So what we're going to do is we're going to take this 5x and replace it into that y there. So it's going to be 2x plus 3, and then where there's a y, we put the other part of the equation, and then we write everything else out. So nothing changed except for what y equals. And then all we're going to do is just your algebra. So 2x plus 15x is equal to 34. Add those two together. Divide by 17. And x is equal to 2. Once you've done this part, you've got x is equal to something. You can either put it into this equation, or you can put it back up into this equation and solve for y. I think this one's the easiest because, well, obviously, you already have y is equal to 5 times something. So if we just put 2 in there, and yes, I know that that one's just mental math, but it's still good for you to see that I substituted it back in, got y is equal to 10, and then I need to make sure that I state my ordered pair, okay? So that's where this ordered pair is where these two lines intersect, okay? Okay, so then our second example, we're going to have 6x minus 2y is equal to negative 4, and then I'm going to have y is equal to 3x plus 2, all right? So then what I'm going to do with those is the same thing. I've already got y's by itself. So I'm just going to take my 6x minus 2, and I'm going to replace 3x plus 2. That equals negative 4. And then I'm going to work through it and then just use my algebra, okay? So 6x minus, and then don't forget, I got to distribute. So that's going to give me 6x, distribute again, minus 4 is equal to negative 4, okay? Well, what's 6x minus 6x? 0, okay? So I have negative 4 is equal to negative 4. Is that true? Yeah, negative 4 equals negative 4. So this is a true statement, okay? Now, because it's true, you want to take a guess out of which of these two is going to give you our solution. Is it no solution or infinitely many solutions? Yeah, perfect. Because when we do our simplification, we simplified everything down. If you get a true statement, that means that it is infinitely many solutions. That means that we're working with the same line. Okay? Okay. Let's go to 3x minus 2y is equal to 12. And this time, we're going to need to do a little algebra. So those are our two equations. Okay. Now, this has a 3x. This is a 2y, right? X and then 2y. Do you understand why I would want to get this x by itself? Because it is by itself. It's just a 1, all right? If I didn't, let's say I wanted to, let's do this 3x right here, right? So if I added the 2y over, right, then I'm going to have to divide by 3 right? So that's fine. I could put that into there and it would be just fine. I could simplify it, but you have to deal with a fraction, right? Whereas if I come over to here and I subtract the 2y, I have whole numbers, okay? It makes it a lot easier. So then this is possible. You definitely can do it, but it makes your math harder, okay? So I don't recommend this stuff here. If I can make it easy, that's what I'm going to go with. So I'm going to take this value, since I just solved for x, I'm going to take all of this, and I'm going to substitute it in for that x, okay? So we're going to go with 3 times negative 2y plus 6 minus 2y is equal to 12. And then I'm just going to go negative 6y plus 18 minus 2y is equal to 12. So I'm going to add those two together. So that gives me negative 8y plus 18 is equal to 12. I'm going to subtract my 18. And divide by negative 8. Is we're going to take this value, what y equals, and we're going to input it into that. So that becomes negative 3/2 plus 6, right? And then do some quick math. So that's 1.5, which would be 5, 4, 4.5. And then so our answer will be 4.5 and 3/4. Okay, so this is going to be our last example in substitution. So again, I see a solo y. That's the one I'm going to go with. So I'm going to subtract 4x to both sides. So I have y is equal to negative 4x plus 11. So I'm going to take this value and I'm going to move it or substitute it into there. So I'm going to have 8x plus 2 times negative 4x plus 11 equals 13. So I have 8x minus 8x plus 22 is equal to 13. 8x minus 8x is, so I'm left with 22 is equal to 13. Is that true? No, this one's false. Okay, so because it's false, that means that we have no solutions, which means what again? Yep, lines are parallel. I guess I should put R. Okay. Okay, so elimination. Again, you're still having your two linear equations. What I want you to remember is when we did stuff like this, okay? We did this vertical addition back in grade school, 3 plus 4, 7, and then we also did like 7 minus 3, which would have been 4, okay? So all we're doing is we're doing that vertical addition or subtraction with equations, all right? Now, what you're going to be looking for is variables that are exactly the same. So I've got two positive b's. I want one of them to cancel out. So that's when I'm going to use my subtraction. So I'm going to go 3a minus 2a, which is just a, which is really nice. B minus b, which is 0. And if you want to put the 0, put the 0. I don't like putting the 0. So I'm going to go 5 minus 10, which is negative 5. So then, once I have that, I have two options. I can either put it into that equation or that equation. I'm going to go with the top. So I'm going to go 3 times negative 5 plus b is equal to 5. 15 plus b is equal to 5. I add my 15. B is equal to 20. So here, oh, I almost forgot. Nobody reminded me. Got to state our answer as an ordered pair. Okay. All right, now, coming back to this equation here, the second one, if I look through, they don't have anything in common, right? Here's the 2x, negative 5x, 8y, negative 20y. I can't just do a simple addition and subtraction. So this is when I need to use my multiplication and multiply it so that I can get something to cancel out. Now, it's your choice which one you want to cancel out. The 20 and the 8, I guess the greatest common factor between those guys would be 40, so that wouldn't be too bad. Or you could work with the 2 and the 5, which would make that one 10, right? So my suggestion would be to work with the x's, okay? So what I'm going to do is I'm going to multiply this one by 5. That means that every term is going to get multiplied by 5. So that becomes 10x plus 40y is equal to 30, all right? And then because I want the x's to cancel out, I'm going to multiply the bottom one by 2. So that gives me negative 10x minus 40y is equal to negative 30. That's going to be nice. So notice that the 10s or the x's here are opposites. So we would just add those together. So 10 plus negative 10, 0. 40y plus negative 40y is 0. 30 plus negative 30 is. So is that true? So if it's true, what do we put? Infinitely many solutions. All right, so our third example, we have 5x plus 4y is equal to negative 14. 3x plus 6y is equal to 6. Off camera, we decided we want to cancel the y's. So the greatest common factor between 4 and 6 is 12. So I'm going to multiply this one by 3 and this one by 2. Now, if I can't remember the greatest common factor between 4 and 6, I could just multiply this one by 6. And I can multiply this one by 4. All right, that works as well. So we're going to have 15x plus 12y, 42. And then I'm going to have 6x plus 12y is equal to 12. So the signs are the same, so I need to subtract. So 15 minus 6 is 9, right? Nobody's screaming at me, so we're good. Negative 42 minus 12 is negative 54. Divide by 9. X is equal to negative 6. And then I can take and I can put it into the 2 original or the 2 that I modified. It doesn't matter. I'm going to go with this one right here. So then I have negative 18 plus 6y is equal to 6. I'm going to add the 18. 24 divided by the 6. Y is equal to 4. So then my answer is negative 6, 4.